Okay, so systems of linear equations is a set of equations involving the same variables. And I can add the solution is an ordered pair x, y. We will get into some special solutions tomorrow, but for today, all of your solutions will be an ordered pair x, y that satisfies both equations. Okay? So let's jump in and do an example so you can see it in action. So let's say that I give you this system of linear equations. You have y is equal to 2x minus 1, and y is equal to a half x plus 2. This squiggly line bracket thing is usually, it's the notation that we use for systems, just to show that these two equations are a system. Okay, so what I'm going to do is I'm going to graph both these lines on the same coordinate plane and see where they cross. Okay, so there's my coordinate plane. This is why graphing skills are super important. You're going to be graphing continually through the rest of your math career. So we have to make sure our skills are sharp. Make sure we have it. Okay, so for this, we're gonna graph the first line first. So the y-intercept is -1. The slope is 2. So I'm going to go up 2 over 1, up 2 over 1, and I'm going to graph my line. Now I'm going to do the same thing with my second equation. My y-intercept is 2. My slope is 1/2. So I'm going to go up 1 over 2, up 1 over 2. You can already see where they're going to cross. Okay, so our point of intersection, where they cross, this is the only point that satisfies both equations. And this point is 2, 3. This is our solution. Now, it is really important that you check that point and make sure that it actually is a solution to both of those equations. So that's what I'm going to do. So my y is 3. So I'm going to do 3 equals 2, and then my x is 2. Sorry, I was doing the math before writing it down, and then it messed me up. Fix that. Okay. Now, we've been doing this long enough now where I'm not going to show you every single step. So 2 times 2 is 4. 4 minus 1 is 3, so I know that this equation works. I'm going to try the next one. Let's see if this works. Half of 2 is 1. 1 plus 2 is 3. We're good. So So if the point works in both equations, you know you've graphed it correctly and you've solved it correctly. If for some reason it doesn't work in one of the equations, then you probably graphed one of the lines incorrectly and you'll need to look at it again. Okay, I want you to try one. And then we'll take a look at some graphs that have special lines. Okay, graph those two and see if you can find the solution. I'm going to start putting my graph up too. Just walking around, it looks like you guys graphed it correctly. So while I'm graphing mine, make sure you check the point in both of your equations to make sure that it actually works. What is the point you guys got? 1, 0. Okay, let's check it out. Yeah, that looks good. So this is the point 1, 0, and I'm going to check it. So this will be 0 equals 1 minus 1. Yep, that's good. And 0 equals a negative 1 plus 1. And yep, that's good too. So it works in both of them. You guys good so far? Okay, let's just try. I'm going to do one more example with a special line so that you can see what that looks like. I know from earlier today that my coordinate plane is going to need to be a little big, so made it a little bit bigger than usual. Okay, so a lot of times you're going to see equations that are special lines. So let's refresh our memory on graphing those. First, we'll do this one. Our y-intercept is negative 3. Our slope is 2. Get that line going. Okay, then for our special lines here, when you zoom in, is that equation going to be a vertical line or a horizontal line? Vertical, okay. We start by just plotting negative 1 on the x-axis. like this. And this is telling us that x is always negative 1. So here it's negative 1, here it's negative 1, here it's negative 1. It just creates a line where x is always negative 1. And where they cross is right here. This point is negative 1, negative 5. And we should also check it to make sure it works. So negative 5 is equal to 2 times negative 1 minus 3. Yep, that's going to work. Now, this one's interesting, right? Because there is no place to put a y, just an x. So we'll plug in our x. And negative 1 is equal to negative 1. So we're good. It works in both equations. You're ready to roll. Any questions for me before I let you work on IXL? Okay, your code today is CC2. And if you have extra time and you didn't finish your code from yesterday, you can go back and work on that. I'll be walking around. Let me know if you guys have questions. And here's the table of contents too.